Welcome to my channel. Here we have a question to solve on the construction of ellipse, and there are important things that we are to find with these questions that we are given. I'm going to read the question, then we go on and solve the problem. The question says that construct an ellipse having a major axis 100 millimeters, minor axis 65 millimeters. Locate its foci, directrices, and find the eccentricity. Let me read the question again. The question says construct an ellipse having a major axis 100 millimeters and minor axis 65 millimeters. Locate its foci, directrices, and find the eccentricity. So we are going to be working on this problem. So the best method to use to solve this problem is to use a concentric circle method, which I believe that you know how to use the method. So if you don't know how to use concentric circle method to construct ellipse, please look for a video on my channel and use it to construct it. So I'm going to pause the video, then I will do the construction, then I will come so that we can find the foci, directrices, and also the eccentricity of the ellipse. That is what we are going to do now. All right, let's do the construction together. I just look at it that let's do it together so that you can learn everything at once here. So the first thing that we are going to do is to draw a circle with diameter 65 by 2, so we give us 32.5. so we take 32.5, so I have to make use of this. So 32.5, so here we have, this is 32.5 here. So we put the pinpoint here and then we draw a circle. So we draw a circle like this, as we are using concentric circle method. And then so we now divide 100, which is the major axis. So that's diameter of the circle, 100 millimeters. So we take 50 millimeters, okay, which is the radius. So then, so putting the pinpoint here, so we draw a circle. So we draw a circle like this. Alright, so we are going to divide this circle into 12 equal parts. So divide the circle into 12 equal parts. So okay. Alright, so we have to divide the circle into 12 equal parts, as I said. So with 30 by 60 degrees set square. So we can go on and divide the circle into 12 equal parts as I'm doing it here. So we slide it to this side and then we draw, so from here to here. Alright, so I decided to show us how to do this because we may have someone who is new to this channel and watching this video. So that is why I decided to do that. So we do it together at once. So alright, so we draw from here to here. So we have divided the circle into 12 equal parts, as you can see here. So I'm going to number the points of the big circle. So this is 1 and this is 0.2, this is 0.3. So here is 4, this is 5, so this is 6, this is 7, here is 8, okay. So here is 9, and then here we have 10, this is 11, and here is 12. So while the point on the small circle, I'm going to number them. So this point, I'll call it 1 prime. So I put it inside. So this is 2 prime. So here is 3 prime. This is 4 prime. Here is 5 prime. This is 6 prime. And this is 7 prime. Here is 8 prime. So this is 9 prime. This is 10. And this is 11 prime. And then here we have 12 for 12 prime. Alright, so we have all this. The next thing that we are going to do is that on this point that we have on this point 2, so the point 3, point 5 prime, okay, point 2 prime, point 3 prime, point 5 prime, and point 6 prime here, point 8 prime on the small circle, point 9 prime, so point 11 prime and point 12 prime. We have to draw a horizontal line, okay. So so we come to this point here for 2 prime and 6 prime. So we draw a horizontal line to this side from 2 prime, and we draw a horizontal line to this side from 6 prime, and then for 3 prime and 5 prime, so we draw a horizontal line from here on 3 prime to this side, and for 5 prime we draw to this side. Then we come up here for 8 prime and 12 prime. So for 12 prime, so we draw a horizontal line to this side, and for 8 prime we draw a horizontal line to this side, okay. And then for 11 prime, so we draw a horizontal line so to this side, and for 9 prime we draw a horizontal line to this side, okay. Alright, so for the point that we have on the major axis, so that is 0.2, 0.3, 0.5, 0.6, so 0.8, 0.9, 0.11 and 12. We have to draw a vertical line, so it goes like this. So coming to that of 2 and 12, so I will draw a vertical line, so from here to touch the horizontal line, and I will draw from 12 to touch the horizontal line. And then for 3 and 11, so I will draw a vertical line from 3 up, and then from 11 down, then coming to this side, so from 5 I will draw a vertical line up to touch the horizontal line, and from 9 I will draw a vertical line to touch the horizontal line. Then from 6, so we draw a vertical line to touch the horizontal line. From 8, so we draw a vertical line to touch the horizontal line. So we have this point. So these are the points that we are going to join together to have the ellipse in place. So let's bring out the points. So by making them shown, so including this point 10 prime on the small circle. So then we have this point. So we have this point. So we also have 0.7 as part of it, and then so we have this point. Then we have this point. So here we have this point 4 prime on the small circle. Then we have this point. Then we have this point, including point 1. So with the French curve, we are going to join this point together. So we take the French curve and then we adjust it. Okay, so we adjust it. So and then so we have this point being joined together. Okay. So we have what we have this. Alright, then we turn to this side. Okay, so for us to complete half of the curve. Okay, so from this point here, so we draw like this to point 1 on the major circle. So it like this. Alright, so then we turn it down here like this. So we adjust the French curve to make sure the points are aligned on the edge of the curve. Okay, so we have this, so it goes so in this direction, so to this point. Alright, so we have this, then we turn it to this side. So we're almost done with the curve, so with the ellipse. Okay, so let me take this so let me just join. Okay, so let me join this together. Alright, so and then so for this, so I join this together like this. Then so we also have this being joined together. Alright, so we have the ellipse in place. Alright, so then the next thing that we are going to do is to locate the foci, the directrices, and also the eccentricity. We have to calculate the eccentricity. So let's look at how we can locate the foci. So the foci, that means we have the focus 1 and focus 2. So to do that, so what we have to do is to take okay, so we are going to take, I will call this point O here. So that is this center point. So we take this distance. So this point here, so this point is the vertex. So I will call it V1, and this is another vertex. This is V2. So we take the distance of the we take OV1 or OV2, anyone that you like. That is half of the major axis. So we take half of the major axis, OV1 or OV2, anyone that will just take any one of them. I'm using left hand, so that's why I'm taking OV2. Okay, all right. So you raise it up like this, having taken half of the major axis OV1 or OV2. So raise it up like this, and then so let's call this point here. Let's call it point C. So let's call this one. Let's call it point C. So this is point C. So that is this point here, and then I will call this point here, I will call it point D. Okay, so that is for the minor axis. Okay, so I put the pinpoint here, having taken OV1 or OV2, I put the pinpoint here at C, then I will make an arc on this line, okay, on the major axis, and I make an arc here on the major axis. So these 2 points, so this point is the focus 1, okay, while this point here is the focus 2, that is F2. So we have located the foci of the ellipse. So then we want to locate the directrix. We want to locate the directrix of the ellipse. So what I'm going to do is that I'm going to extend this line a bit. I will extend this line a little bit to this side, and also let me just extend this one a bit to this side. So what I'm going to do is that, so I'm going to take a point. So I will take a point here. So see if I want to construct a tangent to this ellipse. So I will take a point here, and I'll call this point, I will call it point P. So this is point P here. So then I'm going to join PF1 together. I will join PF1 together like this. Okay, so we join PF1 together. So having joined PF1 together, so I'm going to take my protractor, so set it along this line. So put the big point, put the center point of the protractor here on this point F, and then that's the center point of the protractor, and this line should be on PF1. So this is what I mean. So you set like this. Okay, so the center point is on P, is on F. So it's on F. Then along this 90-degree line, so put a dot on the paper here. So then we are going to draw a line. So from here, all right. So looking at this method that I want to use, it may not work. So I don't want to go on with that. Okay, so as we have joined PF1 together, let's join PF2 together. Let's join PF2 together. We get our work done. So let's join PF2 together. So let's join PF2 together with a straight line. So we have this. Okay. So now, so we are going to bisect the angle between PF1 and PF2. So put the midpoint here at P, and then so draw a small arc. So just like we want to construct a tangent to point P on the ellipse. So with the midpoint here at this point on the arc, so draw an arc like this. Okay, then we put it at this point here. So then we draw an arc like this. Okay, so here we are going to draw a line from this point passing through point P. So it goes like this. So just like we want to construct a normal, a tangent and normal to the curve. Okay, so we have this. So now, so what I'm going to do now to draw to locate the where we are going to have the directrix. So for this side, so I will take my protractor, set it along this line. Okay, so make sure you can see point P a little bit. So and then so we are going to draw a line. So from along this part, so just to touch P a little bit. Okay, so if I extend this line, to this side, so I extend this line to this side like this. Okay, so wherever it touches here, so wherever it touches here, so that will be where we are going to place the directrix. So at this point, so where we have directrix at this point, so I'm going to draw this line. So this is directrix on this side. This line is directrix on this side. So I'm I'll call this line, I'll call it line AA. So AA prime. So then to locate the directrix on this side, so all I have to do is to take this distance from this point. So let me call this point, let me call it point Q. Okay, so if I take distance Q from V1, okay, so then I'll put it at V2 here and then make an arc here. So this line gives us the second directrix of the ellipse. So this is it. Okay, so I'll call this one, I'll call it BB. So B prime. Okay. Alright, so we have answered that question in this case. So the next thing that you are going to do is to calculate the eccentricity of the ellipse, eccentricity of the ellipse. So how do we get the eccentricity? So the eccentricity is E, eccentricity E. So it's going to be equal to, so we have V F1 or Vf over what? Over VQ. That's what we have there. So, and this will be equal to, so if I take a measurement from V to F here, so this gives us, this is around, so this is 13 millimeters. So here I have 13. Okay, so this is 13. So over, so if I take distance of V from Q, so this gives us something like, this is 46. So this is 46. So we have 46 here. So whatever we get here is going to be what? It's going to be 0 point something. So which is the eccentricity of an ellipse. As we know that the eccentricity of an ellipse is less than 1. Okay, so that's going to give us something less than 1. So as simple as I've done it here, all you have to do is to practice. Thank you, keep on practicing, and God bless you.